It's my pleasure to introduce Engineer Sami Sarhan from KAUST Innovation. He's going to talk about technology and application of drones autonomy.
Yes, my name is Sami Sarhan, and I am from KAUST Innovation. Just for a disclaimer, though, I am not representing KAUST Innovation. I'm representing myself here as a pilot and as an advocate for this particular technology. Let's go fast, very quickly. We're going to talk about a little bit of some of the challenges that are coming from the industry. We talk about levels of aerial autonomy. We talk about the difference between mission planning and objective planning, and when autonomous drones would work the best. And we're going to talk about a little bit about technologies and the challenges that we have. If you look at petrochemical plants like that, you understand how complex the preventive maintenance could be and how complex the asset management could be for the maintenance. For example, solar panels, for example, thousands of them. Okay, in order to detect on a daily basis which of the cells are actually not working and not being able. If you want to put a crew that goes around, you know how complex is that. Nowadays, agriculture is moving to precision agriculture. In order to move on to that with the traditional methods, that will be quite difficult and very, very difficult. Finally, in any construction site, you understand there's so many moving parts, understanding progress, understanding near miss, understanding safeties. This could be something very, very difficult. Now, I cannot claim that autonomous drones will solve all of these problems. Obviously, it will not. However, it will definitely reduce it. We think that combining autonomous drones with AI technologies and capabilities might be able to address some of these challenges and most of it. Now, let's take a little bit of just a high-level definitions. Very, very obvious, very, very simple language is the ability to drone to fly autonomously without a pilot or operator's control following a mission and or an objective planning. Okay, so what do we mean by that? Let's take an example very quickly. When you have a mission planning, you set for the drone specific waypoints. Okay, so the drones actually fly from A to B to C and back to A. Now, in mission planning, so for example, this is an example of security. Okay, so let's say there's a security surveillance, or you have a security centers are looking at a specific area, whether headquarters or campus like that. Somebody at the control room will always be available as a pilot, as an operator, will always be looking at the camera, will always be looking at what is going on while the drone is actually flying from point A to point B. That's what we call a mission planning. You still have somebody in the back looking at the drone, still be looking at the actual monitors and being able to identify some of the behaviors that is going on in terms of security. However, before I go and talk about objective planning, I'd like to share with you this beautiful model that actually been done by Axion. It's a level of aerial autonomy. If you go from level 0 to level 5, it's a huge difference. But if we take, for example, level 3, where the operator sets the point of interest and ready to fly. However, in level 5, you actually set objective rather than actual point. I'll explain. I have an example right after the slide where I explain this in more details. Systems filters and limits the conditions in level 3. However, system flies under all or conditions, and so on and so forth. The point is that in mission planning, there is less intelligence and there's less capturing of the surrounding. In full-fledged level 5, obviously, I don't know if we have actually reached to level 5, but there is a lot of data gathering, a lot of input that is happening. Okay, so let's take an example so maybe we can make this a little bit clarifying. Let's say this is a typical construction site, okay? And I'm an engineer, so I worked in constructions for a long time, so I understand this. Let's say you have a construction site and you have a typical drone in a box. What you do in order to reach to objective planning is so you set objective. You tell the drone, I want you to look at a specific area and I want you to tell me the progress that is happening in that area. You also set objective. You identify specific assets like the vehicles and the heavy vehicles that are actually in the grounds. You also set the objective. You want to count, for example, how many vehicles coming in and out. You tell the drones, you put that all in the intelligence of that drones. You also set a specific geometric boundaries. Now you're not giving the drone waypoints. You're actually almost like geofencing. You're telling the drone you can only fly in these particular geometric boundaries. And then you also identify to the drone all the assets that are available in that particular site, all the machineries, all the vehicles, all the equipments that are available. And then, of course, you tell the drone as well what's the work shift that's available. And very important, you tell the drone the actual schedule. And so in constructions, you have this master schedule, and when area A will finish, when area C will finish, and so on and so forth. Then basically the drone will plan its own mission. In a typical drone in a box technology, when that information is available to the drone, you don't have to tell the drone when to fly or when not to fly. The drone will plan its mission. It's basically now it's clear for the drone where are the boundaries, what are the geometric boundaries going to fly. And it's going to send data instantaneously, and going to process data on board right away. So as soon as it finds something, it's actually tell and send that data. But for example, if one of the objective is to know how much progress we have in that construction site inside C, for example, the drone will be able to send that data immediately. Fail-safe and energy control. Let's say the drone, for whatever reasons, is running out of energy or there's a problem. It will go back to its box, it recharge itself and go back and continue the flights. And the most important, anomalous detections, okay? Things that you have not put in there, you wouldn't know it, but at least the drone will actually fly. Let's say you're actually monitoring the number of vehicles coming in. If at one point of time there is a specific heavy vehicles comes into the site, then the drone, at least not knowing exactly, but at least should be able to notice that is not in my database. What is this? At least it will send back. This will become extremely useful. For example, if there's a smoke or there's fire, there's something that is anything abnormal, so the drone should be able to send that information back. Now, I'll make this very, very fast. This is just the difference between autonomous and automated, okay? And a lot of you probably know the autonomous is a lot of the adaptions that is happening. A lot of the intelligence that as the drone is flying is actually adopting and giving more information. It's increasing its database. However, when you do autonomous, well-defined parameters, there's a very restricted areas and a predefined areas you want to fly. Now, let's answer very important questions. When autonomous drones work the best, okay? I think there's multiple areas, but however, let's focus on three of them. When do you need a continuous monitoring? When there is a persistent and consistent basis, you would like to monitor things over and over and over. Then this technology will become very, very useful. Again, going back to construction side, you want to go back again over and over rather than having a pilot flying this every time. You will set your drones and will go out and actually do the flying. Same things when it goes to precision agriculture. That could be a good examples. Another examples is when there is an infrastructures and asset inspections, okay? You will definitely de-risk a lot of the problems and a lot of the challenges that you have with putting a human. For example, on my right, over there at the corner, that's a flare from an oil and gas. Imagine if you have to shut down the flare and put somebody up there just to make sure to check the iron bar right there. The drone actually can fly autonomously, look at the flare, take a nice inspection point for it, and come back. So you're actually de-risking the involvement of human into something like that. And again, the last thing, of course, is not last. There's a lot of other benefits. However, detecting of any abnormalities. Let's say, for example, with AI and machine vision, autonomous drones can be trained to detect abnormality. A typical applications is leaks that happens in gases. So there are actually a beautiful payloads for actually they can sniff gases, and you can actually on autonomous basis you can actually fly the drone in a specific area and tell it, look, cover this area for me and tell me what are the actual gases that is happening, and it will immediately identify those gases for you. Now, let's talk a little bit about technology. So I spoke about some of the challenges, spoke about the differences between mission planning and objective planning, and we spoke about some of the applications. Let's talk about some of the technologies. Very obvious technologies, the type of drones. In autonomous drones, so there's fixed wings, there's multi-routers, and the hybrid as well. Each one of those have its own applications. For example, the fixed wings could be extremely useful when you wanted to cover a bigger area. Let's say a pipeline. You wanted to send the drone away down and be able to inspect for you the pipeline. However, the multi routers could be very nice in a very concise area. If the area is very concise, you can fly around and be able to know. And these are some of the examples of fixed wings and vertical takeoff and landing drones that are available. Again, communications, and I think X-Wing did talk about that. When you want to fly autonomously and want to go a little bit, beyond visual line of sight, then the Wi-Fi and the radio communication might not be enough, for you to get all your data back. There are technologies that are available, LTE or 5G networks are available for that, and of course, SATCOM. I have seen drones with satellites communications on them. And these technologies are already being used in drones. Payloads. Now, payloads are, honestly speaking, without a payload, drone is a toy. Payloads is the one who actually empowered drone and made drone very useful. Now, there are lots of payloads depending on the payloads that you want to put. Then you can actually use that for your autonomous. Now, you have to just be very careful when payload, particularly, especially now when you want to fly your drone autonomously, you want it to go as far as possible. There is the heavier the payload, the shorter the flight, obviously, because you're going to consume more energy. Software and system integrations, obviously AI and machine learning. AI-based drones rely largely on computer visions. There's so much advancements happening in that area. I think that AI will become a very important technology that drones will be using in the future, and being able to identify things that as it goes. Now, and the ability to integrate with multiple systems is very important. Drones itself with the external system, be it a cloud, be it a system in the control room, or the actual payload with the drone itself and control. So the payload should be able to tell and pose and the drone, or even tell the drone, give some interactions with the drone rotors or even the cameras, and be able to tell the drone how it could react. Mission planning software are becoming more and more robust, or moving away from just the mission planning into an objective planning. There are other enablers. For example, we just talked about as well the GPS. The RTK technologies are available for GPS correction technology. Let's say you want to navigate through bridges and you want to be extremely precise to a centimeter. So you wanted to use technologies like real-time kinematics. UTM, I think it's extremely important. Being able to have the unmanned traffic management for drones in a specific area or a city, or even a concise area. So if there are multiple unmanned system flying, you should be able to do appropriate traffic management for those. These are all enabling technology. Now let's talk a little bit about the challenges. Now, I think one of the biggest challenges we have is beyond visual line of sight. Now, flying beyond visual line of sight, according to GACA, which is the Saudi General Authority of Civil Aviation, is a big no-no. You cannot really today fly a drone in Saudi Arabia beyond visual line of sight. In the US, actually, I'm jumping here. In the US, those companies who actually been trying to do that, especially talking about last mile delivery, are actually been approved by FAA 135 rather than FAA 107. Flying over people, it is a challenge. It is a challenge as per the regulations. Again, by the way, just for your information, FAA 107 and GACA 107 is exactly the same thing. In Saudi Arabia, we adopted the FAA 107 right here, not just for drone, I think for manned aircraft. Depending on the drone categories. Now, even in the FA17, they have category 1, 2, and 3, and 4. It is actually a challenge. If you are a small business, you really want to do something very quickly with autonomous drones, you really have to have, and you want to fly over people, and you want to fly beyond visual line of sight, you have to worry about that. So each country, I want to say, has its own regulation. Speaking specifically about Saudi Arabia, we follow the FAA 107 in here. Now, other thing is the energy. I think this is very important as well. You want to be able to fly drone as long as possible. Lithium ion could not be the best solution if you wanted to do something, on a longer base, or you want to send your drone out for a couple of hours. So I think there are a range of energy available for drones, all the way from hydrogens and lithium ions and so on and so forth. Now, finally and last thing, the biggest challenge as well is privacy. So, drones has been tagged by. There are countries who actually completely, extremely rich in privacy. However, there are some countries who do not absolutely care about privacy. This is just a very quick map which countries actually look at privacy as a challenge. Thank you so much.
Thank you very much for your interesting presentation.